Hi, it's Ray from Pro Shaper in Charlton, Massachusetts, and tonight we're going to start the actual TIG welding exploration. It's how to TIG weld. Last night we did a little teaser welding up some aluminum using a technique that I learned from Martin from Netherlands a couple years ago, and I got really good results with that. The comments on that video tonight were, boy, I wish you could weld up some steel. So I figured, well, I was really intending to do aluminum, but a lot of people do steel, and I do a lot of steel too. So I've got some 19 gauge here. I sawed it in half with my bandsaw. I didn't want to have a sheared edge, which is not realistic, but it's a nice tight joint. That's very important, as I mentioned before in the other video. And we're going to be running this TIG welding exploration series along concurrently with the all aluminum bonnet of the E-type that we're building. So if you haven't discovered the my YouTube channel, go to the home page of my YouTube channel, and there's like 100 and I think 10 videos there now, and I've done a whole series that's starting on scratch building and aluminum E-type nose or bonnet. So we're going to start off this welding video with a piece of 19 gauge. I've wheeled it up so it's just not a flat coupon. And like I said, I bandsawed it in half. I removed a little bit of fuzz that the bandsaw leaves. And just to start it off with, I've got this little Chinese sourced welder. A friend of mine bought this thing. Why? I don't have no clue. But I believe he paid $300 for it. That's what he told me, and he bought it on eBay. And he asked me if I would be interested in buying it from him. He never used it. I says, how much you want for it? He says $300. He's a good friend. I gave him the $300. I thought it would be great for my class because a lot of people balk at buying a TIG welder because they figure that they're very expensive. So this was only $300. It came with the regulator and your torch, the ground, and it doesn't have a foot pedal. It only has the on-off switch. It's not regulating of current here at all. It's just on-off. And I found that it works best just by putting it at the lowest setting, which says 10 amps, but it's actually a little warmer than that. It's probably more like 30, but it works fine. So this is DC only, meaning it will only weld steel. So we're going to fire that up, and I'm going to show you a couple techniques in welding this together with that little inexpensive welder. Well, curiosity got to me, and I wondered how much these actually sold for, and yeah, they were selling about $300 on eBay. I found that a company that makes them, I guess, CT312 it's called. I think it's about 120 amp welder or something like that. It won't weld too much thicker than probably 1/8 inch steel. And I haven't really tried the high end on it, but it also, I believe, has another function. It might be a plasma cutter or something too, because it's got this MMA. Well, I don't even know what that is. I'm using the TIG. Let me show you what it does. First off, though, I want to show you how to properly grind a tungsten. And we have it's an air-cooled TIG torch, meaning it doesn't have a water cooler. These air-cooled TIG torches are good for about 130 amps. You can weld. I have one on my Miller here, which is a state-of-the-art 1985 Miller Synchro Wave, and I can weld 1/2 inch thick with that air-cooled torch. So you can weld quite a bit with this, but if you're going to weld a lot of heavy aluminum or something, you really need a water cooler for your TIG welder. I do have one TIG welder in the shop that has a water cooler. It's mobile. If I need extra amperage, I bring that around. So this is a 2% lanthanated. I used to use the 2% thoriated, but this one's lanthanated. It's 3/30 seconds. The grind on it's not too bad, but I'm going to regrind it and show you how to properly grind it. And the proper grinding procedure is you just need a bench grinder, and these 2 fingers and your thumb, that's the rotator right there. Very simple procedure. Boom, boom, boom. You have to grind it like this. You don't grind it like that against the wheel. So if the wheel's here, it's not recommended to grind it that way. It's recommended to grind it this way. Now, some of this stuff will be pretty elementary for some of the other people watching. Bear with me. I'm hoping I'm getting a lot of beginners or people who've been on the threshold of buying a TIG welder but haven't pulled the trigger yet on it. This will convince you to buy a TIG welder. So let me do the grinding of the tungsten over here on the bench grinder. So here's my spinner fingers and thumb, and this is my guide thumb. Hold it up to the wheel. Don't wear gloves. If you wear gloves, the gloves get caught in the wheel, it'll ruin your gloves. It'll probably grab your hand too. If this bites, you'll pull your hand out instinctively, it won't hurt. I've only done it like once. It looks dangerous, but it isn't. You don't stick it in like that. You bring it at an angle like this, and slowly offer it up to the wheel, and then you increase the angle, and you move it back and forth across the wheel so you don't wear a hole in the wheel. You have a little cool bucket there as you get hot. I like a super sharp point and about 1/4 of an inch back. So there we go. Now we're all set. Alright, so the first thing we're going to do is we'll clamp this up. Same procedure as I did in the last video. I always like to clamp from the middle. This joint should be pretty good. It should tighten up pretty nicely. So what we'll do here is we'll try to do the TIG tacks with fusion. I'll show you that. That's a pretty rapid deal. This one does them pretty decent. And overall, I'm really impressed with this little machine. It's incredible. I think you can possibly buy them even cheaper today. But $300 for a TIG welder is pretty inexpensive. So a lot of people are doing rust repair on restorations, and they're repairing a front fender, the lower part of the front fender, or the quarter panel, and generally a lot of people MIG weld stuff on, and this is a much better way. If you're going to do a super first class job, you have to butt weld. If you do a lap weld, it's going to be adequate for a certain amount of time, but it's going to come back and bite you. There's going to be water inclusion in there at some point, no matter how bad, how good you seal it up. And but I prefer butt welding. Now, it's a problem if you've got the quarter panel on the car. A lot of my students will say, well, I've got this problem with the quarter panel. How do I fix it? I can't get in there. Well, the quarter panel is spot welded on. If we're talking 60s cars or even 50s cars, production cars as opposed to coach-built cars. And you're going to have to remove all those spot welds, pull that panel off, fix it on the bench, put the panel back on the car. Now, it sounds like a lot of work, but you know, it can take a day to take all those spot welds out, and you're going to remove that panel, and you're going to find gobs of rust in spots that you don't have access to. So if you're truly restoring the car and you want to keep it for the next 20 years or so, you want to try to retard that rust problem. So if you get the quarter panel off, it's going to expose a lot of inner structure that has rust there. A lot of the inner panel of the quarter panel is going to be rusted. So that's really the only way to do it really a good job. And if you've got the quarter panel off, then you can put patch panels on it, either that you buy or you make, and you can clamp it on the bench, get it all straightened out, put it back on, and do the spot welds again, and then you've got a really first-class repair. And before putting it on, you do all the rust paint prevention that you would do on the backs of the panel and inside inner structure of the panels, and also undercoating and things of that nature. So that's the way to do it properly. If you do shortcuts, you're not going to get first-class job. So TIG welding allows you to do a job that the panel is as good as it came out of the factory if you do it right. So we're going to display this capabilities of this machine. As I mentioned before, this has just an on-off switch. That's it. So we're going to do some tacks. We're going to do some fusion tacks, and then we're going to weld this up a couple different ways. So all I have is this on-off switch. Now some of these welders, not this particular one, but some of them have on-off switches, and some of them have a slider where you have the amperage control plus the on-off. This is the most basic, and it works good. You can actually pulse it with your finger pretty easy. So we're going to try to do some tacks here, and here we go. So I put 3 tacks in there. We're going to move down the line here. Move my clamps out. Now I try to get the tungsten within a 1/16 of the weld pool. You have to watch very carefully, and you'll see whether or not that pool is going to take. Sometimes it wants to open up. If that's the case, then you got to run over to the side a little bit, build the heat up, and then come back and then blast it a little bit. If it starts to open, you got to have a rod ready, and then you can fill the little hole. But I think we're going to be okay here. Alright, that one wants to open up a little bit because there's a little gap here. So I'm going to grab the rod and I'll add a little rod. Very easy. Now I like to put the tacks pretty close, 1/2 inch, 3/8 of an inch apart or so. That seems to do a really good job. And these tacks should go all the way through. We'll take a look at the bottom. Yep, they're going right through. You can see the penetration's perfect. I have a gas lens on there. That gas lens, and it's a number 8 collet. The gas lens will direct the argon. This is just purely argon in this one. Right to the weld seam and give you good protection. Now where this little on-off switch comes in handy if you're welding underneath or underneath the dashboard, underneath the car or something, it's very difficult to work a foot pedal, so the slider or on-off pedal or on-off button works really nice. So my cameraman, all-around web guy, and general shop helper Mark is doing the video here. And the last couple times we videoed, he was in a big hurry to get out of here. Tonight, we're not so much in a hurry, so.
I gotta be out by 10:15.
10:15?
Oh, fuck no.
Yep. That's the first mistake you'll make when you TIG weld, is that I accidentally stuck the rod into the tungsten and I got a little blob of steel on there. When that happens, you have to go grind it. So we'll cut for a minute, I'll grind it again, and we'll be back in business. So there we have it, and you can see that those tacks went right through. You get perfect penetration. The panel is super level here, and this is a step that I like to do on all my steel welding. I do it on the aluminum welding also, but on the aluminum welding it's a little oxide. On the steel welding you have like black fire scale, and I'll take a rotary wire brush, and these are the knotted style. There's also the pinch style that they kind of fly out. These will fly out, but not too frequently like the other ones. So they're a little more expensive, but they work really nice. So we're going to wire brush this. That's the heat affected zone. As you can see from those tacks, the heat affected zone is only 1/4 of an inch on either side of the weld, or either side of the panel. Now, at this point, these tacks are almost as good. In aluminum, the tacks are not as good. In steel, they're excellent. The steel tacks, this is effectively welded together. It's very difficult to break this apart right now. On aluminum, you could take it like this on the edge of the bench, bend it, and it'll break right off. This might do it too, but it'll hang together a lot longer than the aluminum tacks will. Now these are a little proud. Some of my added rod because I was afraid it was going to blow through. You don't want to blow holes in it. If you do blow a hole in, the trick is taking the rod and instead of putting your focus of the heat on the material, you focus the heat more on the rod, and the rod will start to ball up. And then you just kind of drop that ball right in there and melt it right in and fill in holes. I mean, literally, you can have a hole 1/2 inch in diameter and fill that up, no problem. So you're going to probably blow a hole here and there. You can do that with a MIG too, not as easily, but you can. So you've got to learn not to stick the tungsten into the puddle, not to stick the rod into the tungsten, and not to overheat the base metal and blow a hole into the metal. But if you do, it's all correctable. Everything's correctable. So as you get more experience, your errors go less and less. So what we can do now is we can take this and put it in the planishing hammer. I can also take a hammer and dolly, and I can hammer and dolly this right here. But for speed's sake, we'll put it over in my little planishing hammer, and Mark will bring the camera over there and you can see that operation. I have an anvil that has a little bit of crown to it. It's not a flat one. I put a little bit of crown in it. And then I've got, on the finishing hammer, I've got speed control and speed and squeeze control. So. And that takes out the little bit of shrinkage that would happen when you weld that up. Also, it'll level it. It could have been off a little bit, but now it's right on the same level. This panel is acting like one panel. So we'll bring it back over to the welding department, we'll weld it up. As I mentioned before I went to the planishing hammer, you can take the hammer and dolly and you can crush each one of these down. You just want to hear that. If you hear this, you're not hitting. You want to hear the tink, tink, tink. So we're all level. Now we're going to weld it up. We don't need any more clamps. TIG welding is all about being comfortable. You can't approach the panel like this and expect good results. What will happen is you're going to be wandering in and out. You have to rest your arm on something. Sometimes it's the edge of the bench. You might put a board here. If it's on the side of a car, you could tape something on. Anything to get yourself comfortable. So we got the rod, and we'll try a little fusion first, and then we'll add the rod. But I'll hold the rod in my hand anyway, so we'll try an inch or two of fusion right here. So there's the fusion, and we got excellent penetration. Hope Mark can get that penetration. We'll wire brush that so you can see it a little bit better. And let me get my shield on. Saw how small that heat affected zone. It's a little wider than when it was just tacking. Maybe it was a 3/8 of an inch or so. But if you can see that weld bead, that's pretty nice. Now that was all smooth. It distorted a little bit over here, but that'll easily come out with a little hammer because it shrunk a little. The back side, you have a condition where it did penetrate really nicely. There's a spot right here, here, and here that it didn't. Those welds, even though they have a little bit of open in the back, if that was aluminum, I would chase after them, but steel you don't have to. Gas welding of aluminum, you're going to see a lot of that sometimes, and it's not an issue on gas welding aluminum. It is a weak spot if you're going to torture test it, but on practical use of just welding pieces of a fender up or something, it's not going to crack. Not the case here in steel either. So that is with fusion, with no backing or anything. Now we're going to try adding a little rod and see what that looks like. Now the rod I'm using is a 030 rod. You can actually get, I actually have some 020 rod, but I really haven't experimented with it too much. So I'm going to use the 030, which is pretty regular used around here. So, and this is 19 gauge steel. That's 40 thousandths. It's very difficult to get in some parts of the country. It's even getting more difficult here. I can buy it here. It used to be no problem getting it. Now I have to buy a quantity of it. And I will do that if enough people want to buy a quantity of it. I'll buy it and do a group buy type of thing. So here we are. We're going to do another 2 inches. We're going to add a little rod. Now you can pulse this by just flicking this button a little bit. So I pulsed it a little, and I added a little rod. I got a super small bead there. And let's look at the back side. Looks pretty decent. Let's wire brush it. You can see the heat affected zone. It's about a ½ an inch on either side. It'll be the same if I use this Miller single wave. And I can't say enough about the quality of this welder. The arc control on it is really, really good. It's amazing for the price. And my ever diligent web guy and all-round cameraman, Mark, ran over and he found out that we can put these in our Amazon store for $259. That's the price on Amazon. We have a link on our description of each video. If you look at the description of the video on YouTube, scroll down a little bit, there'll be a link and it brings you to the ProShaper Amazon store, and you can purchase it right there. So now we're going to go on to cleaning this fire scale off and really observing what we did. It's hard to see with the fire scale there. So there you have it. Now you can observe it pretty closely. There was less opens. There's a tiny little bit here. So here we are looking at the back, and there's a tiny little open here, but it looks even better than what the other one was. By adding that rod, it gives you the ability to get a little bit of drop through. Now we'll require grinding on this side, so it'll be a light grind on this side. Hardly any grinding at all on this back side. So now let's try something different. This is all unprotected on the back side. Now I've got a piece of copper here, and copper on the back side gives you a backside condition of shielding. So we'll put a clamp here like that. Now we got to make sure that we're up tight with that copper. Otherwise, we won't get that back shielding that we're desiring. So we're going to add rod, and we have the copper backing now. So let's see what kind of result we get this time. So there we have that. Now I didn't pulse it as much, but I did pulse it, which allowed me to put a little more heat into it. And this one, now you can see there's a lot more drop through. So there's what you have from here to here, a little rod, here to here again with the copper, and you can see the backside is really good. There's one spot that's open right there, so it was a little colder there, but again, it's not a problem. One little spot right there. But overall, that's super clean. You should be able to see that. So oftentimes I will use copper if I want a really good backside weld. It just keeps it really nice and clean. So what I'm going to do, I want to do an aluminum piece tonight too, so I don't want to spend too much time on the steel. So let's grind this, and then we'll take it to the power hammer and we'll clean it up, and you can see what it'll look like. Mark asked why was I pulsing the button on here, the on-off button, and that's just another heat control. And when you use pulse on a welder that has pulse, again, it's a heat control, so you're not really showering too much heat onto that panel at any given time. So you're less likely to do blow-throughs, and it makes it a lot simpler to do when you have the pulsing. You can pulse with a foot pedal, you can pulse with this button switch, and you can pulse automatically if the welder has pulse on it. So let's grind here a little bit. And I showed some grinding last night. I'm not going to talk too much about it tonight, but we'll do the procedure the same way. We're going to knock the tops off of here, and then we'll just crush it in. Now again, I'm going to run over to the planishing hammer, but I can do it with just a hammer and dolly. Just walked over a little bit over here. I didn't weld it all to the edge, so let's see if I can get it back. There we go. Came right back. We'll bring it over to the planishing hammer and just give that a light planish. Sand it with the little rotary 2-inch sander and then the orbital, and we should be all set. Okay, that looks very, very nice. That'll sand up very easily. Both sides will look pretty good. This is a hook and loop 80 grit Norton's. And we got 120 grit. This is the hook and loop little 2-inch detail sander, orbital. And there's your finished weld. You can't even perceive it. It's not there. You can clean the backside up even better if you want, but there's one little tiny little spot right here. Sometimes if I'm really persnickety, I'll go in there and weld up that little spot, just to drop a daub on there. But that's what you should expect with all your welds. Small heat zones, heat affected zones, perfect surface control. If you overstretch it, you can use one of my shrinking discs. You'll find my shrinking disc in my website, proshaper.com. I have a whole bunch of sheet metal tools in there. And if it was a little high, you watch my video on how to use the shrinking disc, and you can take that little bit of high out in 2 seconds. But all of your welding in steel or aluminum should look like that, like there's nothing that's been done there. It's just apparent metal. So I hope that helps the guys that wanted to see the steel welding. And this was done, like I said, with a super inexpensive welder. So now we're going to do one other type of aluminum welding of sheet. As I mentioned in my teaser video, which we put up tonight, this will probably go up, Friday night? Friday night. We're going to try to do at least 2 videos every week now. We've been doing 1 a week. We're going to bump it up to 2. And if things all go well, maybe we can even squeeze in 3 videos a week. We're doing the aluminum bonnet, and we're doing the TIG welding. And the TIG welding is so inclusive. There's so many things that you can show with TIG welding. So that could run on for a little bit. And we're talking TIG welding exclusively just for sheet metal, aluminum and steel. And we might do a little bit of copper too, to show you how beautifully copper welds up, and stainless too. So what we're going to do now is I want to show a little bit of contrast between the different machines. And I just showed with steel on this very inexpensive Chinese welder, bare bones welder, and it's steel only machine, and it just does a superb weld. And I don't think you could get any better. It's just perfect. But it will not do aluminum. But this is a 1985 Miller Synchrowave. It was state of the art at the time. And it's an old copper coil machine. It doesn't have pulse, but you can pulse with the foot pedal if you want. So let me get this set up. And for those that are experienced TIG welders, bear with me. I'm going to just give a little setup information here. First, again, I'm using lanthanated on this. I always like to have my cord supported so I don't have the weight of the cord. This just so happened to go in there really nice. That's a nice storage point. So I'm going to grind the tungsten again. I showed that earlier in the video. So I'm just going to go off and grind that tungsten. So I've got the tungsten all ground. It's a 2% lanthanated, I'm sorry. 1/4 of an inch back. I put a super sharp point on it. A lot of people and a lot of the literature says you should, not use a grindstone that's had steel on it, and not use something that like a sandpaper or whatever. I don't find any of that to be true. The cleaning capacity of these welders today is so good. All I generally do is just give it a little wire brush. So I've got this clamped up the exact same way I just clamped up that steel part. You can see the back side, and it's a nice tight joint. I should be able to fusion tack it, and we'll try some fusion tacking with this machine. Maybe we'll fusion tack it and then fusion weld it, half of it, and the other half we'll use a rod. We'll grind it down, clean it, and then we'll torture test it, and I think that'll be it for the night. But I just want to show the capacity and capability of these various machines. And I even have an older Dialac machine that I started off with years ago. And even that machine, you can actually still do a pretty good weld with it. So first we'll start this up. We turn the argon on. This is pure argon in this one, whereas in the Everlast I was using a helium argon 50-50 mix. Switch is here. I never watch the gauges. We're going to be doing aluminum welding. Aluminum welding requires AC. Everything else is going to be DC. And you need continuous high frequency for welding aluminum. We're putting it there. And the amperage we're going to try, let's see, we're going to put it on the low scale, which is the black, and the high scale is the white. So the black is this inner one, and we're going to put it up like 70 amps or so. We'll try that. And the AC balance is another knob that you'll have on this. You have it on the inverter welds too. And the more you put it this way, you get cleaning. The more you put it this way, you get penetration. So anywhere in here will actually work fine. I've got it set about right there. This is the post flow. You get a flow of argon after you stopped welding. That's important to keep a little crater from forming. So I've got it set for like, I don't know, 8 or so. I think that's 8 seconds after you shut off the switch. It'll keep flowing. Start current I'm not using, crater fill I'm not using. This is just for the foot pedal, both the switch and the adjustment on the foot pedal. And that's it. We've got straight polarity. So let's see what we can do. We're going to have to burn the tungsten in first because I ground it. It's a good idea to grind those in. Burn them in, sorry. We got a scrap piece of aluminum here. So there's the tungsten with a super sharp point on it. That's a 2% lanthanated, 330 seconds. This is a number 8 cup with a gas lens on it. My Everlast, I run a number 10 cup with a bigger gas lens. It's a different format. The gas lens improves the gas flow, directs it right on the weld. Very important little accessory. It does a much better job if you have one on it. So we're going to just burn this in. Got to have a foot pedal for this one. Got a little tiny microsphere on the end of that tungsten, and that's what you want. The 2% thoriated would start out really small, but it starts wandering and it'll get bigger. You would have to grind those. After so many linear feet, you'll have to regrind your tungsten. It burns back a little bit. So let's see if we can do the fusion tacks. Now, I haven't been using this for doing aluminum welding for quite a while because I love the Everlast machines. One thing I've noticed right away was it's a lot dirtier than the Everlast, and the Everlast has the helium. I think that's another feature that you'll find in the helium, that it's a lot cleaner. We'll see if this works really good. So you start on the pedal, give it a little, get the current flow to happen, and build the heat up a little bit. Then you nail the pedal a little, and you'll get the nice tack. And it's pretty rapid too. I got a little keyhole started there, so. So there we have it. I'm not going to weld all the way to the end, so just leave it like that. So, very little penetration on the back side, even though we had 70 amps. This is 063 3003 aluminum. You can see there's a little haze around each one of those tacks, and I'm going to clean this up. There's no strength at all in those tacks. It's just merely holding it together. I'm going to put a couple more on the ends here. So I had to add a little rod on the ends, and we'll clean that. We're very level, looks pretty decent, we're nice and clean. And now we're going to run with just fusion. We'll do half and then half with the rod. Then we'll clean it up and do the torture test. Now, let me do the same technique. We'll do the backside welding first to close the back door. So there's our fusion on the back. It looks pretty good. It was cleaned very nice. You see the white cleaning action that the TIG welder does. And we didn't get too much drop through on this side, so the heat was moderate.
Now what kind of brush are you using?
This is a stainless steel brush. They have the much smaller ones. I like this bigger brush like this. Now I'm going to fusion weld it halfway, then I'll add the rod. So. So there we have that, and we got similar drop through like we did last night on the other welder using the Everlast. So now we're going to add a little rod. That might have been a little hot again too. It's getting late. I bugged it up. When you get too close and you put the tungsten, or this was the case, I popped the rod into it. It'll wick right up on your tungsten. Again, this happens a lot when you're a beginner. There's no excuse for me doing it. I'm an abject failure at TIG welding, obviously. So before I put the rod into the tungsten, you can see by adding the rod, that's a pretty good looking weld, and it's positive on this side, and this side here, it's not showing much drop through at all, which is a good condition because the drop through on the bottom is harder to grind, especially if you've got a compound curve here and you've got no way to straighten it out. So this will grind really easily. This might cause a problem, we'll see. So Mark asked me while I was grinding the tungsten, why did you put the amperage where you did? Well, I thought it was about 70, but it's actually about 68 or so. Generally you put your amperage to the thickness of the metal. So if the metal is like 60, you use 60 amps. If you give it a little bit more, that gives you a little ability to moderate with your pedal or your slide on your finger. So I've got 68, not that much more. So the weld's looking really nice here. Now let's see if we can continue on there. So as I'm running the tungsten, I'm also doing a little circular action. That's a nice little trick. One of my students, Joey Allen from Pennsylvania, clued me in on that. And what that does is gives it a little more heat, spreads it out a little bit. I'm doing really small little circles, and that bead's looking really, really nice. So this is why I really prefer adding rod as opposed to just fusion welding. Fusion welding can look really nice sometimes. Adding rod requires you to grind it out and clean it up after, another step that you don't have to do necessarily with fusion welding. But with fusion welding, there can be a lot of problems. Like for instance, in the video last night where I fusion weld that aluminum, you'll see this situation here where we have this lot of drop through. On the edge here, when I ground it, and after I hammered it, there was a little tiny valley right on either side. And when we torture tested it, that valley, which has nothing to do with the welding, was just the fact that it's created by the drop through. If I had ground it instead of hammering it, or ground it first, that valley wouldn't have been created. It's just the condition of if you take an awl and scratch aluminum, that's always where the crack will develop. So because I had that little valley on either side of the weld, you'll notice after I hammered it with the ball peen hammer as hard as I could about 10 times in that last video, it fractured there. It was a fatigue fracture. It was nothing to do with the weld. The weld was as strong as the parent metal. Now we're going to do that after on this one. If we have any cracks in the weld zone itself, generally my theory is what happens is that you just didn't get enough heat into it. You need enough heat for the metal to do what I call the handshake. And this one might be good, we'll find out. But if we do get a crack, it's just because there was not enough heat. That's why I like the helium in the mix instead of straight argon. Helium ensures a really good amount of heat. And heat is one of the benefits of gas welding, because you're throwing a tremendous amount of heat into the panel when you gas weld. It anneals it. Now another thing you can do is after you TIG weld and you've got it all welded, you can spot anneal the weld, and that will make it very similar to a gas weld and a lot less likelihood of any potential problems with your weld. So let's carry on. I'm going to do those little circles and we'll see what we can do. Hopefully it won't stick to tungsten anymore. We got to burn this in. Oh, I got a piece of aluminum right here. I'll burn it in on this one here. Why do I burn it in? Generally, when after you first grind the tungsten, it'll throw a little dirt, and you want to get that ball formed. So that's every time I grind it on aluminum, I will try to remember to burn that tungsten in. Now the little technique, and I almost stuck the rod in again, the little technique you want to do is you have to watch the position of your tungsten, and you want to keep this torch at 90 degrees this way, 90 degrees. But you got to tilt it back a little bit. I say about 70 degrees on the tilt back so you can see what you're doing. Now they do have the glass lenses. That's an improvement. Use a lot more gas, but that's okay because your object is to make a nice, really nice weld. And supposedly the gas lens is only for steel, but I haven't tried them yet, so that is yet to be discovered by me. But the gas lens will offer a little bit better visibility. So maybe I'll get one of those clear lenses. So we did get a little bit of drop through, not much. So we're going to clean this up now. We'll grind her up. All right, so now we're going to clean up those welds. I have the Norton 50 grit. I cut them like that. If you haven't seen how I cut them, let me cut one. Yeah. You put them on. I use an old straight Wiss sheet metal cutter, and I got about a 3/16 gap between the edge of this, cut a straight, and another straight, and another straight. Just keep turning it. It doesn't matter if you're a little asymmetric or not. It's these tips that really do the really good grinding. and you can get a couple grinds out of each one of these little 3-inch discs. And you can put a little candle wax on here, just standard candle wax. So now I got a couple of them I can grind with. And I find these Norton Blazes, B-L-A-Z-E, work really, really good, especially on aluminum. Now we'll try hammering this a little bit. This is where the drop, it hollowed out a little bit. I got a bunch of drop through. I didn't want to grind that all out. So we'll do the hammer and dolly trick again. So see if we can force that extra metal up to the surface. You can see that's pretty malleable. A little bit extra right there. I want to knock that down a little bit. Now, close observation of this, and I actually can see what I believe to be a crack, and I think that's going to fail right there. And that was the case that I always got with the argon, is that you never really knew what was going to happen. Let me look at that with my little loop. Let me get the loop and see that. With the helium, you just don't get that. Yep, that's definitely going to crack right there. I see a crack. So this is the bad rap that TIG welding gets when doing aluminum. Is I've found that it was a hit or miss sometimes. Now it's not a big deal, it's just because it didn't make the handshake. If I re-weld that crack will heal right up, and that might be what we should probably do. So let me see if I can draw there where, no, where's my pen? Right here, okay. So it looks like it's got a crack developing right here. I can see it on this back side here. This looks all good over here. I forget which one was the fusion and which one was the ground one. Should have marked it. And let's see, there might be a crack right there too. A little bit there, yeah. Yeah, generally overall I'd say it looks like it's going to crack in a lot of spots. Now another test, we don't have to torture test, another test is to take this and bend it over the edge of the bench and see if it'll break off, and I think it's going to. So yep, there you go. So you have a failure there. What a great way to start off this series, is showing a failure. And this is why the gas welders scoff at the aluminum TIG welders, because you do get this failure problem. And generally during a class situation, if I did this same exact sample, I would get probably as much as 70% success rate, where you could weld just like I did and get a really good weld. But when I did the torture test, on 30% of the time it would crack. So the next time we do this, keep this in mind what happened with the argon. We're going to be using helium argon, and we're going to be using the pulse, and the addition of those two other elements really made this a foolproof method. So this is a failure. And the gas welding guys are right at this point saying, better go buy your flux. But we'll have a different perspective once we see the next installment, when we go back to the Everlast and we'll use that argon helium mix and the pulse. It's foolproof. So hope I didn't bum you out too much. I wish I had got better results than this, but actually this proved to be very good, very insightful here. So I tried to do a really nice job, and we got the failure that a lot of the gas welders point out all the time. So thanks for watching. It's Ray from Pro Shaper. And I used to watch Red Skelton when I was a young man, and he used to sign off, good night and God bless. Good night.